Everybody, this is B.V.H.RAGHU, ZP High School, PALAPADU, Narsaropet Mandal, Guntur district. Last class, in the last video, we discussed about substitution reactions and addition reactions. And also, we studied about graphite, the third allotropic form of carbon, that is Buckminster fullerene. Today we started with that concept. This is also a very important concept to remember. So just you go through the important points in Buckminster fullerene. Buckminster fullerene, that is C60, are molecules of varying sizes that are composed entirely of carbon. మొత్తము కార్బన్తో కలిసిపోయి ఉన్న అనేక రకాలైన సైజుల్లో ఏర్పడేదే C60 అనేది. The second thing is, what is fullerene? Fullerenes are formed. How the fullerenes are formed? When vaporized carbon condenses in the atmosphere of an inert gas. In the atmosphere of an inert gas కలిగిన atmosphere లో vaporized carbon, వేపర్గా మారిన కార్బన్ కండెన్స్ అయితే అక్కడ fullerenes ఫామ్ అవుతాయి. అట్లా అర్థం చేసుకోండి మీనింగ్ఫుల్గా. Fullerenes are formed when vaporized carbon condenses in the atmosphere of an inert gas. So different shapes of fullerenes are we are observing different shapes, but in your textbook only the spherical fullerene is given. Spherical fullerenes are also called buckyballs. So what is the shape of Buckminster fullerene? Buckminster fullerene, that is C60 molecule with the shape of a soccer ball. Soccer balls, the shape of soccer ball. You see the shape of soccer ball in the next content. So here C60 molecule contains 12 pentagons and 20 hexagons. 12 pentagons. Pentagon means having 5 sides. 20 hexagons. Hexagon means having 6 sides. So in C60 there are 12 pentagons and 20 hexagon faces, and each carbon has sp2 hybridized orbitals. So how many pentagons are there in C60? 12 pentagons and 20 hexagon faces. What hybridization is there in Buckminster fullerene? sp2. Now go for the uses of this C60. This is used as a specific antibiotics to target resistant bacteria. So to resist bacteria ni resist cheyadaniki ఆపడానికి యూజ్ చేసే యాంటీబయాటిక్ లాగా తయారు చేస్తున్నారు. నెక్స్ట్ టార్గెట్ certain cancer cells such as melanoma లాంటి క్యాన్సర్ సెల్స్ని టార్గెట్ చేసి దీన్ని క్యాన్సర్ నుంచి మనము కెన్ రెక్టిఫై ఫ్రమ్ ద క్యాన్సర్. సో నౌ we go for the diagram. This is Buckminster fullerene. See, there are here, this is a hexagon and these are pentagons. If you observe this, there are totally how many pentagons are there? 12 pentagons. If you observe these on one side, there are 6 hexagons and 6 pentagons and 10 hexagons on one side, and on another side there are 6 pentagons and 10 hexagons. Totally 20 hexagons and 12 pentagons. You see, pentagon, this is 1, 2, 3, 4, 5. This is a hexagon. Here is a pentagon. So observing this diagram. So you go through that diagram carefully the diagram is not necessary for examination because it's a difficult diagram. So generally in the examination paper this diagram was not asked. So we just you have to know the information regarding Buckminster Fullerene. Next you go for the next important thing, that is functional groups. Functional groups. See this. Functional groups. Okay. So mainly there are 6 functional groups regarding carbon, hydrogen and oxygen. Containing carbon, hydrogen and oxygen, there are 6 functional groups. What are they? Alcohols, alcohol. Okay, alcohols. What is the general form of alcohol? ROH. What are the examples? CH3OH, CH3, CH2OH. What is the name? CH3OH, methyl alcohol, and another one is ethyl alcohol. You remember these two as an examples for alcohol. Next thing is aldehyde. What is the general form? RCHO. CHO. See here, RCHO. This is H. See, this is HCHO. HCHO, that you call it as formaldehyde. Here CH3CHO. CHO, in that CHO, C and H there is a single bond, C and O there is a double bond, that is acetaldehyde. The next one CH3, CH2, CHO. CH3, CH2 you can write it as C2H5, that you call it as a propanaldehyde. There are 3 examples for aldehyde, you remember that. The next thing is ketone. Ketone, the general form is C double bond O. On that carbon there are 2 bonds. One is R and another one is R dash. In all examples, what is all refers to? R refers to alkyl group. What is the general form of alkyl? CnH2n plus 1. Okay. Example is dimethyl ketone. Formaldehyde. After that. Dimethyl ketone, CH3, C double bond O, CH3, that is dimethyl ketone. On this side there is one methane, on the other side there is another methane, and in between these 2 methyl groups, methyls, at the center C double bond O. What is the general form of ketone? C double bond O. On that carbon, one is R and another one is R dash. This R and R dash are alkyl groups. So this is on one side it is CH3, on the other side another CH3. How many CH3s are there? 2 CH3s. What is CH3? Methyl. 2 means dimethyl ketone. In the second example, ethyl methyl ketone. The next is carboxylic acid, RCOOH. So RCOOH, that is HCOOH, that is formic acid, CH3COOH, that is acetic acid, C2H5COOH, that is propanoic acid. Similarly, ether, the general form is at the center O, on one side R and another side R dash. I told you already, R and R dash are alkyl groups. What is the general form of alkyl group? CnH2n plus 1. Methyl, ethyl, propyl, butyl, these are called alkyls. So here dimethyl ether and ethyl methyl ether. And the last thing is ester. That is RCOOH, that is dimethyl ester. On both sides methyl is there. So one side is ethyl and another side is methyl, that is ethyl methyl ester. So this page, from this page, in the examination paper, many questions asked in different ways. What are the functional groups? And what is the general form of ketone? There is a small matching part. On one side, the functional groups, on the other side, the general forms. And the example of alcohol like that. they are giving the formula, you can write the name of the formula. In that way, you can remember all these things. The next thing, the last thing today is a very important thing, that is isomerism. What is isomerism? This question is also asked in many examinations, right? The isomerism, isomers of butane. What is isomerism? Give an example in that way. What is isomerism? The phenomenon of possessing same molecular formula. The molecular formula is same, but different properties by the compounds is isomerism. The phenomenon of possessing same molecular formula but different properties by the compounds is isomerism. The compounds that exhibit isomerism is called isomers. Isomerism is a process, is a phenomenon. Isomers are the compounds. So first example is butane. So there are two isomers, one is N-butane and isobutane. N-butane అంటే వరుసగా రాసుకోవాలి, స్ట్రైట్ చైన్ రాసుకోవాలి. ఐసోబ్యూటేన్ అంటే ఒక బ్రాంచ్డ్ చైన్ వేసాము. ఇక్కడ అక్కడ కూడా మొత్తం కార్బన్స్ కౌంట్ చేసుకుంటే C4H10 ఉన్నాయి. సో మాలిక్యులర్ ఫార్ములా సేమ్గానే ఉంది, కానీ ఏం డిఫరెంట్గా ఉంది, ప్రాపర్టీస్ డిఫరెంట్గా ఉన్నాయి, అంటే స్ట్రక్చరల్ ఫార్ములా డిఫరెంట్గా ఉంది. నెక్స్ట్, దిస్ ఈజ్ అనదర్ ఎగ్జాంపుల్ ఈస్ N-pentane, C5H10, that is isopentane. Both are having the same molecular formula C5H10, but both are having different properties, that is different structural formulae. Molecular formula is same, structural formula are different. So this is about isomerism. Tomorrow we will discuss about homologous series and the molecular formula, which is an important nomenclature, which is an important concept in organic chemistry, and all other things in the next videos. Please subscribe my channel. Thank you.